Okay, so now we're going to be discussing about source transformation. So what's the idea of source transformation? Source transformation allows us to convert a voltage to a current source, convert independent voltage to current, or vice versa. Now, how do we do that? Well, in this situation, whenever you have a voltage source in series with a resistor, this can be transformed. So let's say this was V and this was R. This can be transformed into a current source with the resistor in parallel. Using Ohm's law, we know that basically this is going to be V divided by R in order to get us that current. Now, if you're given a current source, then you can always convert it back into a voltage source so long as that resistor is in parallel. So this is bidirectional. And that's basically what source transformation is. Now, source transformation remains also as a very quick circuit analysis technique and helps us avoid having to write mesh equations or nodal equations. And sometimes it might not even be necessary for us to write those mesh or nodal equations. We can always maybe find it right away. So source transformation allows us to, quickly get to the answer using, because maybe the circuit allows us to do so. But hey, maybe perhaps you're not convinced. Let's say we have a voltage source like so, and then we have a resistor. Just for, you know, here's another resistor. Here's another resistor. Here's another resistor. And here's a current source. And I ask, what if you wanted the voltage drop across here? So V out. And let's use simple numbers. 1, 2, 3, 4. For voltage, I'm going to go with 12 volts. For current, I'm going to go with zero point 0.2 amps, just to make some logical numbers. But the resistors are still illogical. Okay, so rather than, well, the conventional way we would go about it is maybe we do mesh. There's 3 mesh loops. Okay, that's fine. We know one of them, and then maybe we can find it right away. But I don't want to do that. Maybe perhaps it's going to take too long. Maybe nodal analysis. I mean, we could maybe find the node here and then the node here. That'd be okay. But I don't want to do that either because writing either equations, mesh or nodal, might take too long. And sometimes we don't want to waste our time doing so. So I'm going to use source transformation. So this source transformation allows us to do something like this. I'm going to take a look at this part of the circuit first. So this allows us to convert this voltage and resistor in series with each other into a current source, which with voltage divided by the resistance. In this case, it's going to be 12 amps, maybe an illogical number, like so. Now, as a rule of thumb, just like with mesh or nodal, wherever the problem exists, don't mess with it. Just keep it as it is. So we keep it like so. Like that. That's okay. We have 1 and then we have 2. This is 3, V out, and this is 4. And this is zero point 0.2 amps. So now at this stage, there's a few things we could do. We could maybe source transform this part. we can combine these two and then source transform back. So we use kind of this transformation back and forth to get us to the answer right away. Okay, so let's do that. I'm going to consider this combination first. 1 in parallel with 2. 1 times 2, 1 plus 2. This is going to be 2 over 3. So that's our resistance. What about this transformation? Well, this transformation makes something like this. So I'm going to look at it one at a time. So 2/3 and 2/3 ohm. So the current is in facing in this direction, so we put our polarity in along the same direction. Okay, so we keep 4, and what ends up happening is using Ohm's law, we have 4 times 0.2, or about 8 over 10, which is 0.8 volts. So that's okay. We still keep this. We don't mess with it. Or, whoops, apologies. 3, and then this is V out. Now, lastly, let's transform this back. So we get the following. We have a voltage source. We have the resistor. We have another resistor, which is our 3 ohm one. We have another resistor. So this is 0.8 volts. We have this multiplied by this, 24 over 3, which gives us 8 volts. This one right here is 2/3. Whoops, apologies. So it's going to be 2/3 ohm. This is our output voltage that we want, and this is 4 ohms. Okay, from here, we just use voltage divider. Notice 3 resistors in series and 2 voltage sources opposing each other. Seems like it's fair game that we should know the answer to this, or we should know how to evaluate this. So it's going to be 3 ohms divided by the sum, so it's going to be 2/3 plus 3 plus 4 times 8 volts in reference to 8 volts here, subtract 0.8 volts. And then from here, you can generally just punch it into your calculator and boom, you have your output voltage. So now, hopefully you get to see that source transformation is far more useful in situations where we can apply it. Now, just to give you some advantage and disadvantages, as you can see, advantages is that we can use both transformations back to back and allow us to quickly find our desired quantity right away. The only drawback is that if we don't meet these two, I guess, looks of it, then we can't use it. So, what do I mean? If you have a current source in series, you can't use source transformation. If you have a voltage source in parallel, you can't use it. But you don't need to, mainly because you know what the current is. So you should know what the voltage reflected on the resistance is. Similarly, for this, we use the principle of the fact that because source elements in parallel have the same voltage reading, we therefore can just say we know what the voltage is here. So it's not that useful to use source transformation in these situations. But in the event that we have these, we can definitely use source transformation. Okay, thank you.